Hello and welcome to York Observatory's monthly TeleTube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the AICO Observatory located at York University in Toronto, Ontario, Canada. York TeleTube broadcasts every last Friday of the month at 7:30 p.m. local Toronto time, right here on our YouTube channel. For any questions or comments you have about our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Instagram at our handle YorkU Observatory or on PixelFed at the handle Alani Carswell Observatory. We would like to inform you about the Astronomer in Residence program. This program is a collaboration with the Alani Carswell Observatory with Killarney Provincial Park to host astronomers in the certified dark sky site of Killarney to lead in-person presentations and shows using the park's observatory. Please note that the 2025 season has concluded. Those interested in participating for 2026 are encouraged to keep an eye out for new applications, which are open from February to May for the summer tenures. Also, tune in next Monday at 9 p.m. for our first ever annual holiday episode of our podcast, York Universe. Good evening, everyone. My name is Danelle, and I'm here alongside Arthana, Darius, Puria, and Zach from the Alani Carswell Observatory at York University. We're excited to welcome you tonight for a talk by Observatory member and guest speaker Paul Mackin, who will be diving into the topic of amateur astronomy. The observatory at York campus in Toronto is at York campus in Toronto, and we would like to welcome you to our show to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Takaronto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. Now, Arthana will tell us what's up in the sky tonight. Take it away, Arthana.
Welcome, everyone. Before we get started with the talk, we wanted to give you an update on what you can see tonight. Today, we'll be able to see a couple of planets, including Uranus, Saturn, and Jupiter. And we'll also be able to see a star called Vega, which is one of the brightest stars we can see by eye. The moon is also currently up in its first quarter phase, and all of these objects can be seen by eye, but using a small telescope will always give the best results. Now we'll move on to introduce our guest speaker.
Thank you so much. Greetings, everyone. It is my great pleasure to be here. Today's great guest is Paul Mackin. He's a telecommunications engineer and entrepreneur who, upon retirement, chose to return to university to study astrophysics. He's currently in his third year of the undergraduate physics and astronomy program here at York University. In addition to being a student, he has also participated in research on the electric dipole moment of the electron at York University and is a valuable member of our observatory. You might have seen or heard him in our Monday night York Universe podcasts. Although he is retired, his spirit and thirst for science are still young and strong. Now, everyone, let's give a warm welcome to tonight's speaker. Paul, please take the lead.
Thanks, Poria. I'm just going to take control of the screen here. I'm told that only one presenter can share the screen at a time. So I'll do that. Okay. You should be able to see my screen. Okay. So everyone, hello. My name is Paul Mackin. As Poria in his kind introduction said, I'm an undergraduate student in the astrophysics program at York University. And yes, I also work in the atomic physics lab and at the observatory. It's kind of a dream retirement for me, and we'll get into why in a moment. But today we're going to talk about amateur astronomy and the changing role of amateurs in what I consider the world's most accessible science discipline, and we're going to explore that. But I'll start off by saying that astronomy is the one science where amateurs have in the past and continue to make a significant contribution. And while it's always been significant, it's gotten more so in the last few years for reasons that we'll discuss. So this has been a lifetime hobby for me. I've been an amateur astronomer since I was 12, which lamentably is 54 years ago. I made the transition to studying and working in the field upon retirement. So yes, when I was the age of most of my classmates, and frankly, a good chunk of my professors, Pluto was still a planet. I continue my amateur work in addition to my studies and volunteer work at York University. And I'm going to make a little plug here. One of the little projects that we are working on, and some of the people on this broadcast are in it, is we produce an annual calendar for the observatory, which helps fundraise. And that'll be available in just a few weeks, and we'll be plugging it mercilessly. So it's a great stocking stuffer, but it'll have some of the imagery you actually see tonight in it. But I've seen a lot of changes in astronomy, but as I said, it remains a science where amateurs can make a significant contribution to the scientific body of knowledge. And we're going to explore some of that tonight. But it's unique in a sense because, if you're a cancer researcher, the public doesn't, other than contributing through their participation in studies and whatnot, doesn't really get to make a difference. But if you're an amateur astronomer, if you're a professional astronomer, yes, you will begin to rely on amateurs because there's so many of them. Their equipment is so good, and their knowledge is for someone that's got this label amateur, it is astounding. In fact, the label amateur is shifting. It's now become citizen scientists, and we'll talk more about that in a moment. So what was it like in the 1970s through the 1990s? What did we have? So I sort of tried to draw up a little list here. And, we didn't have mobile or smartphones. And each of these things I'm going to list has a role in astronomy. We didn't have mobile or smartphones. We didn't have the internet. We didn't have sophisticated home computers. We absolutely did not have digital cameras or digital image processing. We didn't have high resolution televisions or displays. We didn't have storage capacity of any kind, let alone high volume storage capacity. And we'll talk more about storage because it's actually key to a lot of this. We didn't have scientific computing tools or scientific, computing languages specifically. And again, we'll explore that. And we didn't have the ability to, one of my engineering degree was in control systems and telecommunications. And we used to use analog systems to control devices. Now we use digital systems, and they're far more accurate, far easily managed, and that's made a big difference to astronomy as well. So amateur astronomy in the 1970s, and I'm going to try and portray a picture of what it was like to be an amateur astronomer when I started. So we had very limited tools. People would often build their own telescopes from the optics up, and that would mean they would go into a room with a bench. So usually a square bench, they could walk around it, and they would grind a Pyrex plate, a borosilicate plate, on top of a glass plate with an abrasive in between, and then you would move a few strokes, and then rotate. You would rotate the glass plate clockwise, and then you'd step counterclockwise in the opposite direction, and you do it again, and you go around, and you would slowly carve out a mirror shape on the glass, and then you would use, once you got roughly the right shape, you'd shift to a finer abrasive, and eventually you'd get to a polish, and you put an optical polish on, and then you would test it to make sure it was the right shape, and then you would send it off to a lab to be coated with aluminum. Then that you would go out and take that mirror, which is the primary piece of a telescope, and you'd go to a construction company and buy something called a sonotube, which was used for pouring concrete. It's a thick, waxed cardboard tube, and that would become your telescope tube. And then you would scrounge around scrap shops to get a bar, a metal bar, which would become the counterweight axis for your telescope. And you'd probably have to splurge and buy a mount drive, and you'd build all this up. And there was absolutely no automation to the telescope you would build. It would have a rough equatorial mount, so it would align with the Earth's equator and the poles, and it would be relatively easy to guide. But you'd have to build these pieces. And I built 4 of them, and I don't think I built any of them in less than a year. So it was probably, 4 years of total work to build these telescopes. So, the tools were quite primitive, and they were hard to come by, and they were expensive. Collaboration between professional and amateur spheres was very limited. Um, astronomers were, amateur astronomers were big on comets and asteroid findings, but it was kind of limited to that. And there was a reason for that, is because there was a very strong emphasis on observational astronomy, and also something called armchair astronomy. Armchair astronomy was for people who didn't really want to go outside and look through a telescope. They wanted to read about it. And they were still involved in the community, but they were, not really active observers. Observational astronomy was getting out there whenever you got a clear night, and dealing with the insects in the summer, and dealing with cold in the winter, and observing. Astrophotography was an option as well, but it was difficult and limited. And to give you an idea how it worked, this was the day of film cameras, right? So you'd have, a camera, like a single lens reflex camera. If you were really lucky, you would specifically have an Olympus OM1, because it was kind of streamlined for astrophotography. And you would hook that up to your telescope. It had film in there, and you would get the telescope lined up on an object. You would carefully open the shutter as not to cause vibrations. And then you would look through the finder scope, try to keep the object, the telescope was going to move on a motor mount, but you had little adjustment knobs to keep it exactly centered for up to an hour while you took a picture. Then you would take your film, you'd maybe do 5 or 6 of these, and then you take your film, and most amateurs process the film themselves. So they would go into a dark room, and they would run the film through a developer, and then a stop bath, and then a fixer, and then put it in an enlarger, and hopefully an image came out, and you could print that paper up. This was, weeks of work to get a single image. And we're going to look at what that process looks like now. But that was a black and white image. If you want to do color, and I did color photography at this time. I couldn't afford to do it, but I had a friend whose parents had a bit of money, and he had a bit of a color lab. But you'd have to have a temperature-controlled sink to keep all your chemicals in, because if the chemicals varied more than 2 degrees in temperature, it would change the color balance. So this was incredibly difficult. So a lot of people avoided astrophotography, and it was really left to more professionals, because they had better gear and expensive university labs and whatnot. But as a result of this, observers developed strong stellar navigation skills. And I want to explain how that worked. And I learned to do this. My grandfather taught me how to do this when I was 12 years old, and I still have the skills to do it. I can still do it now. But you would start with something like the Big Dipper. You can see this is called constellation hopping, and you can see in our picture here we've got the Big Dipper kind of in the center. So you can see it, the stars in the handle are curving down, and there's a little cup at the top. Now, most people, or a lot of people, know the trick that if you take the 2 end stars in the cup and point, it'll point to the North Star Polaris, and that points you to the Little Dipper, which is great. But the Big Dipper is really kind of a signpost, and it's kind of a direction, a map pointer. Because if you take the handle and follow the curve around, it will take you to Arcturus, which is in the constellation of Bodes. And if you go further, it will take you to Spica, which is in the constellation of Virgo. So there's two more. So now you've got the Big Dipper, which is Ursa Major. You've got the Little Dipper, which is Ursa Minor. You've got Bodes, and you've got Virgo. You can navigate in those constellations, and you can identify them. Now you want to find Cassiopeia, which is kind of a big W. And what you do there is you take the middle star from the Big Dipper, and you point that. You run a line from there through Polaris to Cassiopeia. There's that W sign. So now we've got Cassiopeia. If you take the two stars in the other end of the cup and go to the left, you're going to come to Deneb in the constellation of Cygnus. And if you go to the right, you're going to come to Leo. And you can also work out how to get to Vega and how to get to Hercules. By going from one star in the cup through the handle, you get to Hercules. So we could use this as a way to navigate, and then you would take your telescope and move it. And if you were lucky, you had some star charts and a few other things you could use to get it aligned. So amateur astronomers in the 70s and 80s were excellent at stellar navigation. They don't need to be anymore because of the tools. But our observation skills were absolutely amazing in those days, and we did a lot of it. And I still go out and people say, "How do you know?" I'll look at something and say, that's Venus, or that's that star there is Vega, and people say, "How do you know that?" You learn these things, right? But these are the skills that amateurs had. So. Another aspect of this was the social aspect. There were many societies you could belong to, and a lot of those still exist. In Canada, we had the Royal Astronomical Society of Canada, and it was actually, there were a number of centers. There were, in the 70s, there were 10 centers across Canada, and I belonged to the Toronto Center. I didn't live in Toronto, but it was the nearest one to me. And that Toronto Center still exists. Now there's more centers. There's a Hamilton Center and a Mississauga Center, and there's other communities have them as well. And they would have regular meetings and observing events. And then there were also things called star parties. And the star parties often had themes, as I mentioned, building telescopes. There was one I used to go to every year in Vermont, Stellafane, which was the Springfield telescope makers. Great skies, and they specialized in meetings for people who built their own telescopes. There were also publications, but there weren't that many. There was no internet to look things up on. So you had Sky and Telescope, you had Astronomy magazine. Scope was the Toronto Center's publication at the time. And there was some public outreach. The David Dunlop Observatory on Saturday nights would host events. You had to sign up for them. You couldn't really just hop in. They were attendance was limited to a certain number because of regulations for getting into the observatory. And there were other such events. There was also a planetarium in Toronto at the time, the McLaughlin Planetarium, and they hosted events. And they also would do star shows. They had a very famous Christmas show every year where they would talk about the Star of Bethlehem and things like that. That's where telescope makers met as well. And they had an amphitheater, a small amphitheater downstairs where the Toronto Center of the Royal Astronomical Society would have their meetings. So there was a huge social aspect to this as well. If we get into today, the biggest difference has been technology, which has also allowed the amateur, the citizen scientist role in developing the astronomy body of knowledge. And when I say the technology has improved, it is night and day different. It's an entirely different experience, and we're going to explore that in just a second. So we've got breathtakingly powerful tools. The telescopes are highly automated. You don't need to be able to navigate around the constellations anymore. Your telescope can do that for you. We have advanced digital imaging. There's no dark room in my house. I've got a computer. You can process your images quickly and efficiently, usually within minutes of taking them. It's incredible computer integration. From my office, I can control 3 telescopes if I've got them all set up in my backyard. from my home office. I can do that. And if I'm on the road and something's going on, and I can say to my wife, please just take the cap off the telescope, and that's all she needs to do, and I can control it all from away. Um, Data sources, amateurs, citizen scientists can now access publicly available research materials. So, for example, NASA publishes a lot of its satellite data within a day or so of getting it. The Vera Rubin telescope, which is in the process of being commissioned and is coming online, it is going to make all of its material, and that is terabytes per day. It's terabytes per year, sorry, available to the public. And they will be able to look for planets. They will be able to look for supernova. They will be able to look for asteroids. All of that data is available publicly. And this is where I talked about storage being a big thing. We're now producing, exabytes a year of just astronomy and space data. So, the technology that's enabled that is advanced networking, the internet, and storage. But it's still collaborative. Amateur astronomy is still collaborative and a community, but it's now much more aligned with the professional astronomy community. And it's also wider reach. The tools are less expensive and the results can be amazing. And when I say that the tools are less expensive, they're much less expensive. So this is a picture I took of the Trifid Nebula, which I think is M25, using a telescope that costs hundreds of dollars, not thousands. It's tabletop. The skies where I am tonight are kind of spotty. Before I go to bed, I will make a decision on whether to set up this telescope, which will take me about a minute. And once I set it up, I'll spend about another 2 minutes on my on my tablet, telling it what I want it to take pictures of, and then I'll go to bed. And in the morning, it will have all the pictures and it will download them to my computer and I can process them. So this is the level of sophistication now. Also, in around the 1990s, there was a fellow named John Dobson who invented a telescope type called a Dobsonian. And it's a regular reflector like I used to make, but he did it for street astronomy. He was actually in a religious order. He was a Christian brother, and he used to do street astronomy. And what he would do is he came up with plans to design a telescope which could be put together for very few dollars. And you could just set it up on a street and people could come and look at it. This led to the idea of pop-up astronomy, which is something the amateur community does. And these telescopes, you can buy them mass-produced, but they're very inexpensive as well. You can't take pictures with them, but they're optimized for looking through, whereas some of the smart telescopes are optimized for taking pictures. You can't look through them. So there's both worlds there. But again, rather than spending thousands of dollars or spending, a year building a telescope, now if you wanted a good little telescope, it's not hard to get. And I would suggest anyone who's interested in this, join us for our podcast on Monday, because we'll be talking about it. And one little clue, if you see a telescope on sale that promises 500 times magnification, run away. Okay. You don't get telescopes at, I like shopping at Costco, but you don't get good telescopes at Costco. You don't get good telescopes at Walmart. You go to a telescope store, you won't spend a lot of money, and you'll have an amazing experience. So again, this image was captured with a very low-cost telescope, and I copied it. It's actually taken over 3 nights, because then you stack the images on top of each other, and it's I can do better with my bigger scope, but it's really quite a great little image. This is a picture of me and my, I call it the beast. But astronomy is a hobby that grows with you. As you become more comfortable and maybe more enthusiastic, you maybe start to invest a little bit more. And again, this was higher cost, but affordable and equally easy to use. It's highly automated. And again, this is the scope that I mentioned. My wife can just take the lens cover off, and it's good to go if I'm away, or I can set it up in about an hour. It doesn't take long to polar align. It's got a built-in camera. The camera is built into the tube. Again, I had to design all the components and put it together, but all the components were bought off the shelf. And there's lots of guidance on the internet, which is a great source of information. So this shows you how far the hobby has evolved. And then we've got this idea of citizen scientists. Amateurs also work on discovering exoplanets. To give you an idea, in the 1990s was when we started really discovering exoplanets. And now amateurs are working on them. And I will add third-year astronomy students, because several people on this podcast tonight are actually have spent the last month or so discovering an exoplanet, or finding an exoplanet, not discovering a new one, as part of the third-year assignment. But amateurs can do this, classifying galaxies, identifying nova, cosmic explosions, processing telescope and spacecraft images. This is a picture taken by the Juno space probe in orbit around Jupiter. And if you saw the raw data, it wouldn't look anything like this. But a citizen scientist has processed it. And it's not only scientifically interesting, it really does show the storm formations and the jet stream bands on Jupiter very well. But it is also pretty. It's a piece of art. So, and and they can actually sell this art. They can get it and make it available to the public. The one thing that amateurs have always done a good job of is discovering and tracking asteroids and comets. But now they're not doing it by looking through a telescope or this incredibly laborious process of taking pictures and then comparing them. What they're doing now is they're getting access to NASA's solar data or other observatory data. And as I mentioned, the Vera Rubin telescope is going to photograph the entire sky visible from Chile every 3 nights, which is a huge opportunity for people to be able to notice things moving. So that is going to be another area where citizen scientists can really start to move things forward. In terms of asteroid detection, maybe one of the things that Vera Rubin might be able to discover is the long sought for 9th planet in our solar system. It hasn't been found yet. The theory states that it could be there, and citizen scientists could be a big part of that. Citizen scientists are also good for monitoring light pollution and, interestingly, being activists in limiting light pollution. I mentioned stellophane earlier in Springfield, Vermont. And in Springfield, the state of Vermont decided to put, for good and valid reasons, a state prison in Springfield. And there was a real fear that it would destroy the skies with light pollution. So the amateur community there didn't try to stop the prison. They're not those sort of people. But what they did do was they helped design the lighting system for the prison so that it pointed downward with reflectors. No impact to prison security, but managed to reduce light pollution. And the skies in Springfield are still absolutely great. There's also been amateur involvement in recovering lost spacecraft, detecting a signal from lost spacecraft and reporting it to the agency running the spacecraft. They were able to reactivate it. So it is a very exciting world for amateurs, and they're not tolerated by the professional astronomy community. They are valued by the professional astronomy community, because the astronomers by nature love what they do. And I'm now seeing it from both sides of the coin here, as an amateur and as a burgeoning professional. And I can tell you that people really do love this. And so outreach is a big part for both the professional community and the amateur community. And we're our own best advertising. And everyone likes pretty pictures, and we take pretty pictures. So that's kind of a great thing about being an astronomer. there's this whole idea of public outreach. Amateur astronomers are still a community, and a vibrant one. This is taken on top of the atrium at York University, where in the summer, spring and fall months, we host every second week an observing session, which doesn't use our 1 meter or 60 centimeter telescope, but uses more modest telescopes where people can look at objects through an eyepiece. And again, you have to be a little careful with that because, you know, a lot of people are expecting those pretty pictures they've seen on the web or in books. And unless you're very trained on how to look at an object, you won't see a lot of those details. But it's still exciting to be able to look at craters on the moon. It's still exciting to be able to look at Jupiter, this big sort of salmon colored ball with bands on it, and moons. You can see 3 or 4 moons usually around it. Saturn, the rings, these are things that are worth looking at. And we try to show those on top of the atrium in the summer. And really you should come to these events. They're free. York University's on 2 subway stations in the Toronto line. It's easy to get to, and they're fun. Our observatory and the atrium both have elevators if you can't get around and can't handle the stairs. So there's no reason not to come, and we would certainly encourage that. So if you want to get involved, join us for an observatory tour. And keep your eyes open for special events. We have them all the time. One of the things we do is every year we do Doors Open Toronto, and it's worth coming. You can tour the observatory. You can see what's inside those big mysterious domes. Another thing you can do is visit a dark sky area in the summer. If you live in the city, you will not believe what the sky above you looks like in a place that is with a truly dark sky. And this is not an expensive or hard hobby. You can dip your toes in. The easiest way to start is to get a pair of good binoculars. Cost you $100, and you can see craters on the moon with those. You can see Jupiter's moons with those. That's a little harder, but you can do it. So again, the barriers to entry are very, very small. And binoculars are useful if you like birds too. You can go bird watching. So dip your toes in, you'll love it. And so I guess I'll just sort of say thank you to everyone, and I'll now turn this over to my colleagues and see if they have any questions.
Thank you so much, Paul. I'm just going to take back the screen share. Yeah, that was a super interesting talk you just gave us, and we appreciate you taking the time to share your knowledge with us.
It's a pleasure. It's a pleasure, even though it's exam time, and I know everyone here. I know everyone here that's broadcasting has exams starting next week. So that shows people listening to this the level of commitment people have to this field of endeavor.
Yeah, definitely. We actually do have some questions for you, and I will go first. My first question is, do you have a dream observing location that you'd like to go to?
I have a few. Springfield, Vermont is great. Although Canadians are less inclined to visit the States right now, but it's not my absolute favorite. So in 1996, the summer in Canada of 1996, it was the winter in Australia. I was doing some work in Brisbane, Australia, and a friend of mine, I had the weekend free, and a friend of mine suggested I rent a car and go up to a place called Noosa. And it's about an hour and a half drive north of Brisbane. And I drove up there, and Friday night I got there late and sort of had dinner and went to bed. But Saturday walked around. It's a very pretty place, Hastings Street, with lots of cafes and shops and things like that. And then on Saturday night I went down and tried to find somewhere to eat, and someone recommended that there was a great restaurant on the beach. So I went down to the beach, and I was sitting there and having my dinner, and it was quite dark. There were a few lights, but I could look out and see the skies. And it just so happened coincidentally, Comet Hyakutake was in the sky at that point, and there was this beautiful image. I could see Hyakutake, I could see the Southern Cross, I could see one of the Magellan clouds. I didn't know the Southern Hemisphere skies at all, but it was breathtaking. And it was many years later, I had a chance, multiple chances to go back. And by this point, Brisbane had upped the public transit system. So you could actually, if you were in downtown Brisbane, you could take, the public transit, trains and a bus to Noosa in 90 minutes. And I got up there and I went down to the beach and I took a camera and I carefully took my jacket off and I put the jacket on the sand because I didn't want to get sand in my camera. And I carefully laid the camera down and I opened the shutter for about 30 seconds, and I got a great sky image. But I was able to see there again a Magellan cloud, the Southern Cross, and I was able to identify the star Alpha Centauri, which is the closest star to us, and it's just a stunningly beautiful place to be. There are better skies in the world, but it's kind of got to be my favorite. Although I'm also, we're in a time where Canadian content is important and good. This year, I'm planning on going to a star party in Saskatchewan, and I'm going to have to drive, which is going to be because I'm taking telescopes and they're big. The Saskatchewan Sky Party, which is in Cypress Hills Interprovincial Park between the Alberta and Saskatchewan borders, and it is the best sky in Canada. It's a 1 rating on a 9 scale, which is the best. And Toronto's about a 9, the worst. So I'm really looking forward to that in Cypress Hills Interprovincial Park, again between Saskatchewan and Alberta borders, and that's next August. So I may have a new favorite spot after that, but right now,
Nice.
Noosa Head in Queensland, Australia, is where I would go.
Nice. That's a cool story about the Australian location, and I'm sure you're looking forward to going to Saskatchewan too. And that one's a little bit more accessible for us.
Well, it's a 4-day drive, but
Yeah.
if
Still,
anyone
it's
wants
not
to volunteer, if anyone wants to volunteer to be my co-pilot,
yeah.
it'd be great.
I have another question for you. What are you excited to observe in the upcoming month?
Yeah, it's a good question. I mean, my personal favorite time to observe is the summer, because there's just so many great objects to take pictures of. But winter is not uninteresting. Orion just offers so much to observe, and Orion's interesting because you can also use it for a bit of constellation hopping, the belt of Orion, the shoulder stars, and so on. So, for example, if you take the belt of Orion and sort of go down to the left, it points to a very bright star, which is the brightest star in the sky, called Sirius, in the constellation of Canis Major. You can, again, learn these tricks. But Orion also has the Great Nebula in Orion and the Horsehead Nebula, so that's exciting. The Pleiades are always wonderful. Again, back to the binocular story, they look amazing in a pair of 8 by 35 to 10 by 50 binoculars. So that's fantastic. There's a few other objects, but Orion offers a lot to look at, and it's prime right now. Jupiter is also, if you're interested in planets, Saturn's still in the sky, but Jupiter's coming into its prime right now. I think it's in opposition in January. So that means around now it's probably rising about 45 minutes after sunset and with us for the rest of the night. So yeah, those are a couple of things. I'd look at Orion, I'd look at Taurus and the Pleiades, and certainly take a look at Jupiter.
Awesome. Those are really great options. Arthana has a question for you next.
Hi, Paul. Thank you so much for your presentation. So my question is, what tips do you have for beginner and amateur observers when investing in a telescope?
I was asked this question 5 or 6 years ago by a colleague of mine before I retired. Her twin daughters, were kind of interested in astronomy. And I found a small desktop Dobsonian for about $200, and I can't remember the brand. Uh, and that was a pretty good deal. I mean, uh, depends on your price range. I mean, if you really don't want to spend a lot of money, a pair of binoculars is a great start. But if you want a telescope to look through, a small Dobsonian, so say that would go between, I don't know, $200 to $500, maybe $600. And there's a number of different brands out there. Scott, I don't want to name any specifically, so I'll name several. Skywatcher, Celestron has them. Orion has them. There's a lot of different brands out there, and they're little industry secret. They're all manufactured basically in the same plant. So, their optics are very similar and whatnot. If you want to get into more what I call comfort astronomy, so you do it all from indoors, then you would get into a smart telescope. And this is where it gets really interesting, actually. You can get a very inexpensive smart telescope, and I'm going to mention one brand, but there are others, and it's just the only brand I know off the top of my head. ZWO, a Chinese company, produces something called the S30 and another telescope called the S50, and they are quite inexpensive, going between about $400 and $600. Depending on which of the two models you get. And that picture I took of the Trifid Nebula was taken with one of those. And the learning curve is take it out of the box, download the app, put it on your table, rotate it until it tells you it's aligned, and then tell it what you want to take a picture of. And you'll be sitting there with your tablet, you're taking the picture, and there'll be a blank screen in front of you. And then after about 10 seconds, there'll be the outline of something. And about 10 seconds later, it starts to get a little firmer. And 10 seconds after that, you can start to recognize it. And then the image just is built up frame by frame by frame. It takes a bunch of 10-second exposures and stacks them on top of each other. And it is the most joyous and satisfying experience you can imagine. Now, ZWO is one brand. There are other brands that do the same thing. Celestron has one, and theirs is much more expensive, but it is also a better telescope. So I would start, if you want to get something you can just look through the eyepiece at the moon with, or see Jupiter's moons and Jupiter's bands. A low-end Dobsonian is a great idea. If you want something a little more sophisticated, something like a very small smart telescope, great way to start.
Thank you. So honestly, it is so much easier nowadays to just, get into observing, just like you said, buy a pair of binoculars and things like that. So I'm really glad that it's more accessible to people now. And my next question is, what resources would you recommend for people interested in astrophotography?
Right. So this is a really interesting point, because I talked about the really difficult experience in astrophotography when I started out. So the first thing is, unless you're shooting the moon or something like that, a regular camera is probably no longer the way to go, like a regular digital, a DLSR, mirrored or non-mirrored. They're a little heavier. So there are some optimized. If you've got if you've got something like my what I call my Beast. It's got a dedicated camera, and again, there's a number of manufacturers that make them, and these are, you can get them. You can get them just for optimized for planetary images. You can get them optimized for deep space images. You can get them that are more versatile, that do both. You can, these are you can directly download over the internet or by plugging in to your computer, and you can image process them. And then when it comes to image processing, again, we're past the time where we have to develop film. There's a lot of great tools and a lot of great software tools, numerous tools that you can try that really automate that process. There are tools equivalent to Photoshop in astronomy as well. So you can start to look at those depending on your comfort with image processing and so on. But a dedicated digital camera for astrophotography is something, if you're serious, if you're getting more interested and more serious about it, definitely the way I'd go. And if you just want to be a beginner, but you go the route of a smart telescope, hey, it's all in there for you. It's already there. It's got the sensor, it's got the software. You don't need to do anything. You don't even need to do the image processing. It'll do it for you.
Sounds great. Thank you so much.
No worries.
So thank you so much, Paul, for your amazing talk tonight. Thanks so much. So my
Appreciate it.
first question is about light pollution. Most of us live in a huge city, and observing is not the best, so to speak. What are your tips to overcome this problem?
Yeah, yeah. This is a joke. I was talking to one of the professors at York the other day, and we're doing exoplanet measurements. And the signal we got was very noisy. It's a technical matter, but that is a problem of light pollution. And I've had to come up with a solution to deal with it. And there are statistical and mathematical things you can do to deal with that. But the simplest solution would be to take our 1 meter observatory and move it 200 kilometers north. Unfortunately, then we wouldn't be having observatory tours every week. So there's a couple of different ways to address this. Number one, if you want to go to dark skies, there are dark sky preserves all over Ontario. The nearest one to the GTA is in Gravenhurst, up in the Muskokas. Okay, it's available. It's open all year. It's free. You go there, look it up. You can just look up Ontario Dark Sky Preserves. There's another one up in Lion's Head, which is a little further away on the way to Tobermory. There's one in Oliphant on Lake Huron in Blue County. There's several towards Peterborough. They're all over. You can absolutely find. You can find dark sky preserves and go to them. But even at that, you don't need to do, you don't need to do that. You know, just go for a drive up north and find a dark secluded road, go down it where there's no lights, pull over, and if the sky is clear, get out of the car with a cup of coffee in your hand. Let your eyes adjust for 5 minutes. Just dark adjust for 5 minutes and look up. And my God, you will absolutely be shocked at how beautiful the sky is. So, unfortunately, you can't really fix it, except maybe you can. And I told the story about the prison in Vermont. So, we replace lights in our cities with some regularity. And one of the things that I've seen in some locations is initiatives to reduce light pollution. And it really isn't that hard to do. All you have to do is choose your lights a little more carefully and put reflectors on them so the light is focused downward. Now, this has two effects. Number one, it reduces light pollution. And number two, it saves money because you can have lower power lights. If more of the light is reflected down than going up into space, suddenly you're saving a little money. So, that's more of a longer term political action thing that the astronomy community is engaged in. So that is definitely something you can do on the subject of light pollution.
Amazing. Thank you so much. So for my next question is that how hard is it to clean your personal telescope? I'm sure it's not as easy as using a glass cleaner and a cloth, definitely.
So you you do use a microfiber cloth, but you're
Wait,
very
you do?
careful. Yeah, you do. You do. You use a microfiber cloth. So it depends on the type of telescope. Um, my both my telescopes are basically have either a lens at the front. Well, I have four telescopes. So one of them's a Dobsonian. I've had it for 20 years. I've never cleaned it because when it's not outside, I've got a cover that goes on it. that keeps the optics absolutely clean. So that's the first thing: is don't put your telescopes in a place where they're going to get the optics are going to get dirty. If you do get something, a cleaning liquid, which are available, and a microfiber cloth, gently, and a bit of an air, maybe a can of compressed air, will get you a long way. Much the same as cleaning a camera lens. What's more interesting to me, and something you do have to do, is to culminate your optics from time to time. And to do that, that takes, something like a small smart telescope. You're never going to have to do this. But if you've got a more sophisticated telescope, then you need a laser. You need to mount it. You need to basically align the optics, and you do that with moving some position screws and a few other things. But culmination is more something I focus on than cleaning. Cleaning is something you can avoid doing very often. So, but you do use standard optical cleaning tools to do it.
Amazing. Thank you so much, Paul. I'm just gonna, and now I'm gonna let Zach ask his question. Sorry, Darius ask his questions.
Thanks, Boria. Hey, Paul. That was a great talk. Thank you. Can you hear me right now? Because I think my headphones died. I just want to make sure that
I can hear you fine. I can hear you fine.
Great. Thank you. My question for you is, what objects in the sky would you recommend to start with for a newcomer to the field of astronomy?
Well, I had a slide on that. I'd start with the Big Dipper. It's easy to find. You kind of look north. And it will be your guidepost for everything. So in the Big Dipper, and I do this almost every time I take out my small telescope, the middle star in the handle of the Big Dipper is a binary star. It's two stars together. They're orbiting each other, Mizar and Algol. And what you can do in a pair of binoculars, you can separate these. You can look at them and see it's two separate stars. And I remember I was the very first time I was living in the country up in north of where I live now, a place called Jackson's Point, and the skies there were very good then. They're not so good now there. But I was walking down the road in the middle of winter with my grandfather, who was the one that taught me about constellation hopping. And we grabbed a pair. We had a pair of old Richardy binoculars. They weren't very good, but they were good enough. And I looked at Mizar, and I could see there was two stars there, and that was a huge thrill for me. And so that's a great place to start. Another great place to start in the winter is to look at Orion. And if you look at the belt of Orion, hanging down below the belt, it's supposed to be the sword of Orion, and that is the Great Nebula in Orion. And if you look at it again through even with your eye, you can see if the skies are good. It's kind of fuzzy, and if you look at it through binoculars, you can make out there's a gas cloud there with quite a bit of definition. Another really great place to start. It seems so obvious. The moon. Nothing better than looking at the moon and just getting that thrill of seeing those craters. It's and then this is something I like to do personally. When I look at the moon, I look at the craters, I look at the surface of the moon, and I say to myself, people have been there. And that just opens your mind to so many possibilities. So that's where I go. I look at the Big Dipper, Mizar and Algol. I definitely look at Orion and take a look at the belt. And the moon is nice and close enough that people have been there, and it looks great almost any way you look at
it. Definitely keep my eyes peeled. Thank you. And my other question is, where have you gone to experience the best observing conditions? So the spots you've been where you've found that it was just the most jaw-dropping, or maybe the least light pollution, or whatever you've experienced.
Sure. Yeah. So, well, I did mention Brisbane, Australia. Or sorry, near outside Brisbane. That didn't have the best sky conditions on our scale, from 1 being excellent and 9 being terrible. It was a 3. So it wasn't bad, but just the location and everything else was marvelous, and it was pretty good. Springfield, Vermont, that's a 2, and they have excellent sky conditions. But the best place I've ever done is I was fortunate enough to spend a number of years in the Canadian Arctic, and wonderful place. Um, uh, Yellowknife was a city that I absolutely love, and I love the people there. Um, if you driving outside Yellowknife, if you've got clear skies, you will get a couple of things. You will get northern lights on an epic scale, and there's no pollution, no light pollution, no air pollution, amazing skies. And I'm told if you're an angler, I am not, best fishing in the country. So there's a lot of good reasons to go to the Northwest Territories, skies being one of them. Again, bitterly cold, but in the winter, and the winter is definitely the best time to be there because that's when you'll see the northern lights. In the summer, they don't really get much. They don't really get much night, so the winter's the time to go. And it's actually a bit of a tourist thing because if you're staying at the Yellowknife Inn, there's regular tours that come in from Japan just to look at the northern lights, and there's some rather amusing stories about that we won't get into today. But I really like the skies up there. But somewhere closer, again, I'm hoping the world changes a little bit, and I can feel comfortable to go back to the States because within driving distance, Springfield is really great. Did we lose Darius's headphones? We might have.
So sorry about that. Yeah, it did happen again. Anyway,
Yeah,
I'm gonna
okay.
step to Zach. Go for it, Zach.
Hi, Paul. Loved your talk. I do have a couple questions. First one is, what are some free tools and software you would suggest to beginner amateur astronomers for data analysis and reduction?
Yeah, Zach. So there's a lot to choose from, and a little bit of it is budget driven, right? Uh, so first of all, if we go back to our telescope choices, if you've got something like one of those little inexpensive smart telescopes I mentioned, they often have the tools built in, and you don't. I mean, you can go beyond that. You don't need to. If you don't want to spend any money on this, Cyril, there's a program called Cyril, which is very good. I find it a little cryptic to use, but it's a good tool and it's absolutely free. Uh, and it has robust and rich capabilities. So you can do a huge amount of you can do your image processing. You can do your data reduction. You anything you should be able to do with astrophotography software. It has it. And then what I would usually do, and I actually do this with the output of my little smart telescope as well, is then I run it through something like Lightroom, which gives you some very easy tools to basically a bit of extra saturation, maybe increase the contrast a little bit. So you can. There's a thing called the histogram. You can stretch the histogram relatively easy in Lightroom. There are other ways to do it, but I find that as a nice little step. But the output. From the smart telescopes is pretty good. And then if you've got a more sophisticated one, the one I use, and it's not cheap, but it's not ridiculous either. I think it's about 300 euros. It's a one-time license. Is PixInsight, which is, if Cyril's cryptic, PixInsight is a mystery wrapped in an enigma. It is incredibly complicated to use, but once you learn it, it is so rich and powerful. So some of the images that you saw tonight in my presentation that were mine are PixInsight images taken with quote unquote the beast. So it is a very rich, powerful platform. But again, you can go. Cyril can do most of what PixInsight can do, and it does it for free. So it's really a matter of your budget, your ability to manage a computer program, your understanding of photography, basically, because it's a lot of the same tools that are in Lightroom and Photoshop. But again, the cheap and dirty way to go if you're just starting, that smart telescope can do it all for you.
All right, thank you so much. My next question is, what is the most fascinating example of independent research that you've seen from the amateur astronomy community?
Well, I think we'd have to go with the time-honored asteroids and comets, although exoplanet verification is becoming a big one. So that's definitely something I would look at. But I actually think that the best is yet to come. It's going to be amateurs getting access to the Vera Rubin data. Uh, we're going to discover so much. We're going to discover so much. We're going to discover thousands, thousands, and thousands of asteroids. We're going to possibly discover new planets. We are going to discover numerous Kuiper Belt objects. Um, uh, we're going to discover more nova than you can imagine. You know, there's a big thing going on right now that we've got, I think, the third interstellar comet going through the solar system right now, 3 Atlas, and it's a comet. It's not a spacecraft, but okay. Um, you know, we've discovered three, and the tools are now available that we can discover three. The expectation is that Vera Rubin will discover one a year. I actually think Vera Rubin is going to discover a lot more than that, and amateurs will be the ones driving that, not professionals. There's not enough professionals, and there's a lot of amateurs. And with the tools like we've got, and the amount of data that needs to be processed, the only way to do that is with an engaged citizen scientist community. So, you know, more of the same, but good heavens, there's going to be a lot more of the same.
You're right, that is fascinating. Well, this concludes our presentation. Thank you for joining us this evening. We will be back with another amazing TeleTube episode on Friday, January 30th, 2026. You can reach us by email at observe@yorku.ca or visit us on social media. On Instagram, we are at Yorku Observatory. On Facebook, we are Alan I. Carswell Obs, and our website is yorku.ca/science/observatory. Have a good night and clear skies.